Today I'll be explaining Torricelli's law based on a project.
Torricelli's law is derived from the principle of conservation of energy. It essentially states that the speed of a fluid flowing out of a hole in a container is the same as the speed that a particle would have if it were dropped from the same height as the fluid surface of the orifice level, assuming no energy losses due to friction or other forces. It comes from the equation where v is the speed of the fluid, g is the acceleration due to gravity, which is approximately 9.81 meters per second squared. H is the height of the fluid above the orifice. Here's now the Torricelli law explained in an experiment. The first thing for this experiment is to drill holes into a water bottle. Fill it up with water and cover up the holes, take off the lid and the covering, and we can see now how Torricelli's law is applied. In hole number 1, the water exits with the least speed, resulting in a short, weak jet. In hole number 2, the water exits with a moderate speed, resulting in a stronger, further-reaching jet. And in hole number 3, the water exits with the greatest speed, resulting in the strongest and farthest-reaching jet. How does the Torricelli law apply in this experiment? As in speeds of water, the water will exit fastest from hole 3, which is near the bottom, and the slowest from hole 1, which is near the top. The jets of water from each hole will have different velocities, and this will travel to different distances before hitting a ground or dispersing. Torricelli's law states that the volume of a fluid leaking from a container is directly proportional to the size of the hole and the pressure of the fluid. Is mostly applied on this law is water pressure. This is the force that water exerts on the wall of its container due to its weight. That's why we took off the bottle cap in this experiment. Water pressure increases with depth because the weight of the water above adds more force. The higher the water column above a hole, the faster the water will exit from that hole. This law allows us to predict the speed of water exiting the holes at different heights in the water bottle. This principle can be observed directly by different strengths and distances of the water jets from each hole.